The final theory piece I want to talk about before we go into our first demo, by the way, we're going to talk more theory later on, but I want to get into our first demo. Theory-wise, I said if one link goes down, the other link is going to take over, or backup link is going to take over. How long does that take? By default, it takes a whopping 50 seconds, which I think is a very long time to wait for a network to be restored. For example, let's say that I've got a link that was in blocking. It's used to receiving a frame coming down from the root bridge every so often. It's called if you want to write this in your notes, it's called a BPDU, a Bridge Protocol Data Unit. A Bridge Protocol Data Unit sort of identifies who is the root, what's their priority, what's their bid, basically. And if I stop receiving that, I'm going to receive those on a blocking port, by the way. My blocking port is not sending user data, but I'm still receiving those BPDUs. And if I stop seeing those BPDUs for a period of time, I'm going to think, uh-oh, something's happened to the root. This is no longer the way I get to the root. It must be some other port, or who knows? Maybe it went down. Maybe I'm the root. So it has to figure out its place in the topology. It gives a grace period of 20 seconds. It will remain in a blocking state for 20 seconds. And if it doesn't hear anything, if it doesn't hear any BPDUs, it thinks something's up. Let's start transitioning this blocking port to be a forwarding port. And then it moves in to the listening stage. Here, it's listening to BPDUs off of all of its ports. It's comparing it to its own bridge ID. It's trying to determine, all right, who is the root bridge? Which of my ports are designated in root ports? Am I the root bridge? Is somebody else the root bridge? It does that during the listening state. And then it goes into the learning stage for 15 seconds. This is where it starts to repopulate its MAC address table, because the MAC address table it had is now going to be wrong, because the way to get to things that used to be on this port, suddenly they're going to come in on this previously blocked port. So it's watching MAC addresses come in, and it's trying to update that MAC address table. So 20 seconds in blocking, 15 seconds in listing, 15 seconds in learning. That's 50 seconds before we transitioning to a forwarding state. That's a long time. The great news is there is a faster way of doing it, and it's called rapid spanning tree protocol that we're going to take a look at in just a moment.